2011, 2010, summer 2010 construction started. 2011, the doors opened, there was an opening ceremonies, and in just a few months ago in December 2011, the first schools, docent teachers and their students began coming in and using the telescope to capture images of celestial objects. One thing that I wanted to bring out here, and this is where the Titan pad is going to come in, I'm going to let Andy speak in a minute while I try to get your email set up for that. Community partnerships really do enrich learning opportunities, and part of the conversation that I want to have with you all today is an awareness, developing an awareness of who our community partners are. I know in small rural schools and even larger schools, it's very easy to feel like you're in a little box and you're by yourself. Sometimes your schools have good frameworks or networks for you to collaborate with other individuals. Sometimes that collaboration is harder, or sometimes those that you are afforded the opportunity to collaborate with don't share the vision or have their own agenda that isn't flexible and able to reconcile with where you want to go. But the communities around here are filled with tremendous resources, and this is one example of, they were just neighbors and friends, people on the street and in the villages that got together and rallied behind this dream and made this a reality. So this is one example in a very small town, and we all have these resources. So part of my request to all of you is to take some time today and identify who your resources are and how you might be able to collaborate with them with your students. So I'm going to let Andy speak to the Observatory of Climate Change. And about 10 years ago, just before we left, one of the gentlemen that we worked with a lot of climate change modelers, and they took ground truth data and then extrapolated it to like national levels or global levels. And so it was pretty far-fetched. There was a big bridge that they were making between what we were doing on a very local scale to what was happening or what their global projections were. And there was one gentleman that we worked with named Mike Pallas, who was at that time working in the Amazon forest, and he was studying climate change data from there. And automated sampling generates a plethora of data. You have so much data you can hardly make heads or tails of it. And he was also a musician, and he developed an idea. He said, what if we combine music and the data? And so every range of CO2 levels had a different note value, and he composed the data set. And he just did that in, I think he used Excel at the time, and just had, if your value is between X and Y, then it's an A and a B and a B sharp or whatever. And he composed the data set, and we listened to it. And it was pretty eye-opening. I hadn't thought of that before. And 10 years later, he's still doing this, and he's not the only one doing this. But one of his current projects is called Boolean Science, and they are using bubbles, methane bubbles, or bubbles that are emitted from wetlands, and using audio sensors to capture when a bubble bursts. And based on the volume of the burst, they can interpolate how much methane is released. And these bubble bursts are responsible for more methane released than any static flux or regular daily flux between the wetland and the air around it. So these bursts were a pretty hot topic, but nobody really knew how to catch them before. And so they are using sound to automatically detect potential volumes of methane gas being emitted from wetlands. So he's still at it, and the project, that current project, that's what this diagram is up in the top left corner. It's one of his wells, or one of the wells that they're using, and they have this sensor here connected to a data logger, and it just automatically records and transfers the information. So their project is funded, this current project is funded for 4 years. It's international. And someone's small idea in a small town, Durham, New Hampshire, is now an international endeavor that people are trying to apply in different regions and get it ground tested. The actual idea behind his work in this instant came from his experience snorkeling or scuba diving with dolphins, and he was with some biologists, wildlife biologists, and they were listening to dolphin and whale sounds and interpreting that data. So he took a tool used in one environment and brought it into a new environment in an innovative way to solve a real-world problem. individual that I've gleaned a lot of information from is Bobby McFerrin. When I was growing up, I knew him as "Don't worry, be happy." That always stuck. But what is more notable now than anything is his work in science and song, and science and music, and brain theories, neuroscience, and how our brains and bodies interpret music, and also more recently how it goes up into the whole world. And so this is a short little clip.
Albert Einstein dreamed of finding what he called a unified theory. And by that he meant a single idea, a single principle, maybe even a single equation that might describe everything in the universe. He worked long and hard many decades to try to find this theory, and he never did. Since his passing, many physicists have taken up where he left off. And many of us believe that an approach called string theory may be the unified theory that he was looking for. And the basic idea of this unified description of all matter is pretty straightforward. You know, if you take any piece of material, say a piece of wood, cut it in half again, keep on cutting into ever smaller pieces. The basic question is, what's the smallest piece that you get to? What's the finest uncuttable constituent? Now, we all know that you cut fine enough, you get molecules. If you cut them up, you get atoms. If you cut them up even further, you get other particles, electrons going around the nucleus with neutrons and protons, and we even know that inside the neutrons and protons are smaller entities called quarks. The conventional ideas stop there. String theory comes along and says there may be one more layer of structure. Inside an electron, inside a quark, inside any particle you've ever heard of, according to these ideas, is a little tiny filament, looks like a little string, that's why it's called string theory, and the little strings can vibrate in different patterns. So the idea is that, according to this theory, an electron might be a string vibrating in one pattern. You can call it a middle C if you want, by the musical analogy. A quark would be a string vibrating in a different pattern, like an A. So the difference between one particle and another is simply the note that its string is playing. And this is the unified description that this theory puts forward. Everything can be reduced to the notes that these fundamental strings are playing. Now that's metaphorical. There's math behind this that allows us to see how all of the key elements of physics can find a home in this description. But in a nutshell, that's what this theory says.
And there is a video that was released a few years ago. It's called Music, Instinct, Science, and Song. And there's a short little clip from here that I would like to showcase.
Humpback whale song is different.
For our school. And having worked with the observatory, one of our other teachers, two other teachers from the district are also docents at the observatory. And so one of our units was astronomy, so we got together and developed a plan that included bringing our students together to celebrate and learn about astronomy. And these are the students from Barnet and Walden School. They're 7th and 8th graders, and there's about 60 of them there. And they're all very different. They're all very unique. They all have their own interests. They all have their own backgrounds. They all come to the table with whatever garbage or riches were put on their breakfast plate in the morning, and they go home and re-enter their real world when they are done at the end of the day. So reaching all of these learners, and those are only a small sampling, is difficult, and one size does not fit all. Another merit for bringing the arts into STEM is that science can be very complex, and even this middle diagram is the mind map. I used inspiration for this presentation, and I hadn't really done it with a presentation before, but I'm going to toggle between this presentation that is here and the mind map that generated it. And instead of doing these items separately, you can actually go from a plan view to a mind map, mind concept view to the presentation almost all in one. It's pretty remarkable. So this is how I planned this presentation, but here's Galileo's works when he was looking at Jupiter's moons here and the lunar phases around our Earth. And you know, he was challenging some pretty rigid ideas back in the 1600s when he said the Earth is not the center of the universe, the sun is. And you know, he was certainly challenged and chastised and criticized for his innovative thinking. So I'm going to take a deep breath and try Bjork and see what she has to offer, because